screen here. I mean, if they're both open on the weekend, firm B makes 1 million and firm A makes 6 million.
Yes.
So I mean, that's just, hey, look it up in the table. Does firm B have a dominant strategy? And this is where I don't
Well, let me see.
necessarily know how to answer this. So let's see here. Firm B, there's break even here. They gain 1 million here. They lose 2. I would say firm B does not have a dominant strategy because they it's almost better for them not to be open on the weekend.
All right, so let's see. So open on the weekend for firm A, 6 million, more than 5 million. Open on the weekend. Yeah. So, all right. So I had to make like the little tick marks or whatever next to them because otherwise I can't like follow along. Because my eyes will keep on darting from place to place. Let me go get a pencil real quick.
All right, so like to me,
I'm back. Here we go.
Here, that's a -5, -2, +1, and a 0.
Yeah, and that's all for firm A. Wait, no, that's for firm B, right?
That's for firm B because we're looking at it in terms of firm B. Firm B is, or firm A, it's like, yeah, let's, they're good with a lot of things here because they're, by comparison, they're +5, +2, 0, and -1.
That's very true. All right, let me pull up the other sheet. See if I can find it. All right. So now we gotta look for which is more. All right. So we know that firm B does not have the dominant solution here.
No, I don't think so.
But we do know that firm A has a dominant strategy. Okay, so for one, if firm A and B are open on the weekend, how much profit does each firm earn? Okay, if both are open on the weekend.
And that we already addressed that, but I'll scroll up here. That's just looking at this first top left corner.
That's just being able to read. 1 million for firm A, for firm B, B, and what's that? 6 million for firm A.
Yes.
A. All right, there we go. Does firm B have a dominant strategy? No.
Yeah, and that's where it actually seems that their dominant strategy would be to not be open on the weekend because that's where they have the best. To me, they have the best. This is their best strategy.
Okay, so we're looking at firm B. Firm B, 2 million is less than 4 million. They're making more money there than the other firm.
It's the only one where they make money. Is if they had an option, they would say let's not be open on the weekend and B not open, A not open on the weekend.
B4. So there's this dominant strategy for firm B, and I don't really need to put like a huge explanation there. I just have to say like which is more than which. So let's see. They would do a strategy because let's see here. Yeah, more than. Oh god. It's really hard to do the explanations because the numbers get mixed in my head.
Yeah, that's why that's why you kind of make the ones that matter kind of stand out. The fact that it's +1 for them.
I'm gonna circle back to the dominant strategy thing. Let's go on to number 3. The payoff matrix in the prisoner's dilemma implies that A, each player has an incentive to benefit the other. B, neither player has an incentive to cheat. C, both players are better off if they cooperate. D, no dominant strategy exists in case of mutual interdependence. And E, non-competitive equilibrium always benefits both players.
So the basis of this is what I understand. I think this is correct with the answer, but um, both players are generally better off if they cooperate.
Yes.
Did your instructor talk about this? Is where you put two people are accused of a crime. They take one in one room, one in the other,
Yeah.
and they you don't know whether it's like, hey, your friend just turned on you. Are you going to turn on your friend? And you don't even know if that's true or not.
Mm-hmm.
It's better if you guys work. If it's better if you say nothing, or say it's generally when you in that scenario where you give in that the it
Or
doesn't work
both
out.
get or both to get the least amount of punishment.
Yes, exactly.
Yeah.
Exactly.
The only problem is that you don't know which one is
Yeah, you don't
gonna
know which
lie and
friend is,
which one's actually like.
and that's why they separate you.
Mhm. That's very smart. All right.
By the way, if you ever get caught in a bad situation, what the police do is I only know this sort of ancillary is they ask you to tell the story over and over again in
To
multiple
find
different
all the loopholes.
and then they ask you to tell it from forward to back, backwards to forwards, and it's really hard to keep a lie straight
Lie straight if you
if
don't know
you
every.
if you don't know every detail.
If you don't know it inside out, you're screwed.
Oh. Okay. Best player's best action, regardless of the action taken by the other player in the game, is known as.
Cooperate.
I think it's their
Cooperative
dominant.
equilibrium.
I thought it was their dominant strategy.
Oh wait, never mind. We're circling those. No
Yeah.
wonder. Okay, so this one is not. Oh wait, so
To me it's B. It's the dominant strategy.
mhm. Best action. Yeah, dominant strategy. You gotta have that, otherwise, nothing really works out there.
So it
All
works
right.
out best for you, and that's all you care about if you're only in it for yourself.
Wait, so for 3, let's go back to that. I didn't know which one to circle. Yeah,
3.
better off if they cooperate, right?
Yes, that's 3 is C.
All right. So what is all right? Now on to another one. All right,
Yeah.
what is Bree's dominant strategy? Let's see. So we have 500, 400, 550, 580 on that side.
So again, what I think you have to do it in terms of Bree here. She's minus 200, minus 50,
Yes.
minus
Bree.
170,
Oh yeah.
and minus 30. So
Wait, is it?
it's like which is the best for her?
Wait, isn't that like 370 or something for top right?
Yeah, 270. Thank you.
All right.
Um,
Let's take a look. So
so to me, the best one is here.
she doesn't have a dominant strategy at all.
Yeah, and there's no one where she does well.
Yeah, because Brayton can advertise and not advertise and still make a ton of money,
Yes.
but she has no, really doesn't like. Yeah, average.
You just step away for 30 seconds. Be right back.
Go ahead.
right, I'm back.
Yeah.
Have you do you feel like you've sufficiently answered question 5?
Not yet. I'm still trying to figure out how to explain it.
Well, in there's no case where she should like that. There's no scenario that works out best for Bree.
Yeah, there's no
So this is, and I don't even know if they cover this here, but there's mini min.
mini-min. Okay.
You're trying to minimize your worst case scenario, which is this one. If you're comparing, one to the other, which I think you do. The other way to look at it, which I guess I really don't know, is like this is the lowest dollar amount, 440.
Mm-hmm.
So that's another one. Like if you're looking at it as like your pure cost, well, that's 440 is the worst. But I don't know to what extent you're doing that here. You could almost say that there is no dominant strategy, but I tend to think that there is there's I think there's always I think there's always a dominant strategy.
For both? Oh. Huh.
No. But I mean, I think there's always a dominant strategy. Like there has to be one. There's not. It's not like you. So again, my best advice would be to put something down about not to advertise for Bree.
Yeah, for Bree, no advertise. The way that they're structured out, it always confuses me. All right, so not advertising. Yeah, she makes more money not advertising, and then advertising. Yeah, not advertising.
I think we can talk about. There also should be like some background to this, like is the advertising, is spending more money good or spending less money good? But we'll just go off the same situation we did here. So the number 6 is the other person's dominant strategy, and it's not too bad to describe, because you just look at it from the other perspective. It's like, okay, if they advertise, they're $200 ahead. This one's 270. This one's 30, and this one is
For
plus
6,
50.
I do know that's going to be Brayton's is really obvious. It's just not to advertise because $710 is more than $700.
Yeah, and then while Bree advertises.
Yeah, Bree has no real, can't really compete with him in this case. Let's see, 700. Come on, use the dollar sign. 700. There we go. What is the Nash equilibrium for this game? Oh my! This is the part where I have a little bit of a headache. Hmm. Nash equilibrium. If you're talking, you're muted.
Oh, I'm sorry about that. I was looking up a solution to this, but the you can verify whether there's a Nash equilibrium if there's a strategy that maximizes both.
Both. Oh, okay.
And I don't know that we have that here. Like we did.
Yeah, there's no real Nash equilibrium.
So I don't know that there is one, and I think that's okay because each cell you can say, well, like the one that benefits Bree was this one in the lower right. The one that benefits Brayton is in the top right. So those aren't the same. There is no equilibrium.
That's interesting. I want to look at my notes and see if there was really anything about that. Here we go. All right, back to Nash equilibrium back here. Let's take a look. I think that there are times where there is no Nash equilibrium, but I don't know how you explain that.
You try to explain each outcome, and you have to say, if why each one is not the Nash equilibrium.
Why each one isn't or is
not. So like the top left, you would say, well, that's not the preferred for either of them. You know that Bree would prefer to be down here in the lower right, and Brayton would be up here in the top left, top right. So that since those don't overlap, so like this is preferred for Brayton. This is preferred for Bree.
Yeah.
They neither of them want that. Neither of them want that. So therefore,
Oh, there are two Nash equilibriums. Okay.
well, only if they overlap. I mean, like I think it's only if they overlap, but I'm not sure. Not 100% sure on that.
The Nash equilibrium thing is the hardest part for me.
So the Nash equilibrium, each player chooses the strategy that maximizes his or her expected payoff. So I guess there could be more than one. It doesn't.
Because I have had a lot of examples in my homework where I've had two Nash equilibriums.
Okay, then you got them here. Then it's this top right, bottom right.
Wait, look for the one that makes the most money. So there's one to the right, makes the most money to the left.
I think 8 we have to compare them together. Oh, there's 9 and 10 as well.
How about we move on to 8 because this is kind of hurting my head. Let's look at if you're talking, you're muted right now.
No, I'm sorry. Just did you get down what you need to get down for 7? So snip 8 in.
Yeah, let's get to 8.
Okay, so it says if the two firms could collude with under design jointly on their advertising strategy, what combination of strategies would generate the great profit for these two? This is now where you got to add up the values in each cells and see which one is the best. So that that's 1200, 50, 1150, 1190. So there's your max.
500, 700. Okay.
Yeah.
Both would advertise for total, well, I say total revenue of, how about just total profit? Total profit of $1,200.
Yeah.
If they were to collude. All right. 9, the market characteristic that ensures that that economic profit is reduced to 0 and the LR is a monopolistically competitive market is.
It's the entry and exit of new firms. It's just a definition.
Okay. No, not that. There we go. All right. On number 10. Draw and correct. Okay, I'm gonna have to graph that.
So the graph here, this is always tough. I have to just find one. So we're looking at a monopolistic competitive firm operating at a loss.
I know that the ATC is gonna be above the equilibrium. That's how you know that they're losing.
What's really, Jack, I know you're in a class here with this, but there's in real life, you actually, real businesses, you know that you understand these things, and you don't actually do certain, I mean, that you do what they say, but it's much more straightforward than that. I mean, it's, you just,
Then
you're
draw
like,
and graph.
you don't draw graphs. Like if I have a person, I have several people that work for me, and there's scenarios where I do keep us going because our variable cost equals our marginal cost, revenues, or whatever it is. But I don't do that forever. Like eventually, I'm like, oh, this isn't working, or oh, this is working, so I can keep doing it. So, you said long run,
This one is when they're operating
short
in
run?
the short run.
Yeah. So I mean, there's so many of these graphs.
It gets confusing.
So here's one. I think this would work for you. Um, your marginal revenue. I don't know what DARP is, but you got your marginal cost and your average total cost, and you've got this window here though where you're operating at a loss in the short run.
I think it means marginal revenue equals demand for the Mr. DARP line.
Okay.
That's the loss.
There's others though. I don't want to just have you. There's another one here that might be a little bit clearer picture.
Operating at a loss. So it means that the ATC is above the what do you call it? The
Average total
equilibrium.
cost, marginal cost. I don't know. The equilibrium price.
Okay, above the equilibrium. Okay. Let's move on to number 11.
Oh, is there another number 11?
Yeah.
Oh wow, there's more. Okay. Use the following payoff matrix for the pricing. Okay, so it's yet another one. Is the dominant strategy for West Side TV? Okay. All right, let me grab the table.
Let's see. West Side TV. What is their dominant strategy?
So we're trying to figure out, do they have one where they make the most money relative to the other one?
I'm actually just gonna highlight one red and the other yellow or something.
So so like, yeah, one of the things you can always do is well, actually, I got to make sure that I get the right one. Is the second number for West Side? I think it is. I'm going to assume the second number is for that, but you said highlight. Let me highlight.
Yeah, that's what I'm doing because I'm not gonna be able to keep track of it if I don't highlight it.
Yeah, I understand. View, draw. All right, so we got that guy, that guy, that guy, that guy. Okay.
Eastside TV, I'm gonna do that in red.
So like when I'm looking at this, for the West Side, the first one here, the first cell is a break even. This is a minus 60,000. This one's a 0, and this one's a plus 60,000. So to me, them advertising in Eastside TV, no advertising is best. So if they advertise, they could lose. Is to advertise. So if they advertise, they can either get 0 or get 160,000. So that's better than not to advertise. So if they not advertise, they could lose 60,000. Is to do whatever Eastside TV does. Well, that's not really true.
Aren't they losing 30,000 though? If they don't advertise versus advertising?
Yeah, I'm just looking at the comparison here. The 130 is 70 is
Oh
60,000
yeah.
more.
Okay.
It
Oh, I
looks
see.
like it's this is to do the opposite of what Eastside TV does.
Mm-hmm. Let's see. So 100K,
Wait,
132.
wait, let me make sure. No, that's not true. Because they don't want that situation. If they no advertise, they want to advertise and no advertise. If they advertise, well, so it's not, to me, it's not here, but clearly your instructor knows that your instructor must know, really. I mean, they must have this cleared, but if they do whatever Eastside TV does, that's either top left or bottom right. That's a 0-0.
Okay.
That I don't know. That doesn't seem right, because it seems like if they were to always advertise, they would either get 0 or 60,000, which is way better than to not advertise. So I guess I would go A here if it were me. That there's some basis to that.
Go A. So, so advertise. Yeah, they should advertise. No advertising, bad. Yeah, I'm not sure if they really do have a strategy, do they? So they should do the advertising for.
Well,
Wait, does it? Wait, does don't
there's
they make
always a
like less money like for? Oh, yeah.
well, it's certainly not no advertising, because they could lose 60,000 compared to
Mhm.
the other ones.
Yes, it would
So
not be good. Yeah, their strategy is advertise. My bad. Yeah, you're right. I was just checking over. Excuse me. All right, 12. The dominant strategy for Eastside TV. Let's see. Hmm.
so for Eastside TV, um, is it the same set of things here? Okay. All right.
Oh, they do have a dominant strategy. They can just not advertise and make more. Because make the same for the right and make a little bit, make 60,000 more if they do, if West does end up advertising, right?
If they advertise, they make 0-0-0. If they don't advertise, they can lose 60, or they can be 0, and here it's plus 60. So to me, it seems like they should advertise.
Oh yeah, you are right. Never mind. I'm looking at the table the wrong way. I end up looking at it weirdly. Yeah, their dominant strategy is to
I
advertise.
guess. I mean, then the thing is they should both do the same thing. They should either both advertise or both not advertise, because if they're working together, because neither of them loses out, I guess.
All right, on the number 13. If the two firms in the cable TV market in Tucson both collude, then both firms wait. Neither of them would want to. Well,
Oh, if they I'm sorry. So if they collude, it looks like the total there is what. Um,
yeah, they would definitely collude for no advertising.
and that's
'Cause
B. Looks like 13 is
both of them
B.
not advertising, earn 150 each. Yeah, that seems like the most logical one. All right, on to number 14. Suppose that each of the two firms has the independent choice to advertise its product or not to advertise. If neither advertises, each gets $20 million in profit. If both advertise, their profits will be 10 million. Wait,
I
so
think
we're
this one
making a new one,
you're being asked to draw some sort of
a new graph.
a new graph, a new table here. All right. If neither advertises to get 20 million in profit, like that sounds pretty good right now.
Mhm.
If they both advertise, their profit will be 10 million each. Well, that's not as good as that one.
Mhm.
If one advertises while the other does not, the advertiser gets 25 million, while the other gets 4 million. So that's 29.
Yeah.
So it seems like they should neither will advertise. Like that's the best option. So you could make a advertise. They both get 20.
Yeah.
Okay. If I'm sorry, if neither, I'm sorry.
No way, independent choice though. So they're most likely going to go for more money. So they're going to go for uh both will try advertising. Wait, each firm will randomly determine to advertise. That's what I think will happen. Right?
Well, to me, it's the best. Like, which is the best payoff for because they work together. Oh, they're
Oh
not
wait,
working together. Independent
independent
choice.
choice. It would be random. That's what I think.
So not they both get 20 million. If they both advertise 10 10. If one advertises well there's not, the advertiser gets
20 and
25
then 40.
0
So,
and then
wait,
0 and
4
then
million.
4.
No, wait, the other one gets 4 million profit, doesn't it? Oh,
If the advertiser
oh,
gets,
my
I mean,
bad.
it seems
I
like
thought that was
they're missing one of the possibilities, at least, I mean, where this is the way that it plays out to me. I mean, it seems like it's better for firm, I don't know, if this is firm one, which we don't know, because it doesn't really say. If this is firm one, if they advertise, they either get 25 or they get 10.
Mhm.
Whereas if they don't advertise, they would get 20 or 0. Maybe I'm looking at the wrong. Maybe this is one. It's always so confusing. Firm one, they were looking at the first column here. If they, the 20, they add, yeah, it's always confusing. So I actually think it's one of these other ones. It depends which one is firm one, which one it is. Will not advertise in firm two. I think it's either B or C because and it depends on which one is 1 and 2. Because if you look down this, it's a 35 versus a 20.
Mhm.
And so that's why it seems like that's and it's just these I don't know. Firm one will not advertise in either of these cases. No, they not advertise. Firm two will advertise. So advertise. Advertise. I'm not sure. Let me check. I mean, probably should put all these in the internet to begin with, but
I feel like it's randomly because it's both independent choice and one they can gamble to get 25K and 25 million. I mean,
well, we're in luck here. It says that both will advertise. Maybe we made
both
this
will advertise.
maybe we made this more complicated because
Oh, independent choice. Oh, as in they can both collude. Then it would. Oh, okay. I had no idea that they could, and that's unfortunate. We spent way too much time on that. All right. Can we go back to the other ones and just kind of check up on the work?
sure. Which ones do you mean?
Like number 13, 12, and 11.
I mean, you've got my best. You got my best information on these. I can look. I can check for them online, but if 13, if they can both collude, they're both going to choose the one that gives them the most money.
Yeah, of course.
Um, so, and then 12 is the dominant strategy. Um, and it's a little weird because I guess it's the first number for them. I think I think they're right. I think it's to advertise in both cases. That would be my best guess, best information for those.
It's the Nash Equilibrium thing that really gets me.
Yeah, I know this doesn't help you, but I've been wanting to do a deep dive into this because it really shouldn't be that complicated. And there's not enough good information on this topic out there for people.
Yeah, it's a very complicated topic. For me, at least, because I'm not very good at it.
I would strongly recommend we move to something else that I can better help you with at the time.
I actually overestimated how long this would take, and so I went for 2 lessons. Can I use my spare one for another day?
Yeah, I'd like to schedule that now with you.
Okay.
What's your best guess? Do you think you need something tomorrow or Sunday or Monday?
I feel like I'll end up using it tomorrow, but
All right, so let me tentatively put it up. What time tomorrow do you want? An evening?
yeah, can you do like 9:30 by any chance? Or is that iffy?
You're cutting into my personal time.
Sorry.
No, that's okay. It's okay. I'm kidding. I'm kidding. Yeah, I can. You know what? You're a great customer, Jack. And yeah, I'll make it for now. I assume you got some swim or something. That's why you need to do it.
Yeah, it takes a while.
Yeah, let's do that.
I can move it to another day. It doesn't have to be
No.
tomorrow.
I'm happy to do it. I'm just gonna move it right now. Use the same booking link, but it'll be at 9:30, and it's fine. You don't want to know how late I'm up, but it's never an issue. So I'll send you the notes and the screen recording out shortly then for this.
All right.
Thanks, Jack. Is there anything else we're gonna cover? We got a little time here. Or are we good for the night?
You mind if we just do like some Pythagorean Theorem thing real quick? This worksheet that I forgot to do. That's really easy.
Yeah, send it over. We'll get some time here.
All right, let's get this. This should not take that long. This is very light work. Let's see. Let's see. Make a copy. Oh wait. Oh no, it's one of these. I'm about to download it because it's really wonky. Either that or. Yeah, I'll download it through Cammy and send it to you. Get an export. Go to the booking link right about here. I'll send it to the reply under a 9 o'clock email. And then attachment, download. Wait, what? Didn't download. Come on. There we go. All right. Now I'm going to send it in there. There we go. Should be at the bottom.
All right, just checking the inbox here and see what we got.
How easy this is. Yeah. I'm just gonna do this and just send it to my phone real quick.
All right, find the missing side of each triangle. Is that the one?
Yeah, that is it.
All right, we'll get through these pretty quickly. All right, so the first one is a Pythagorean triple. These are ones you want to know. 5, 12, 13 is one. So x equals 5. If you know this, and there's many of these, there's an infinite number actually, there really is no work. But if you want to show work, it's x squared plus 12 squared equals 13 squared. But when you get down to x equals 5, you say, maybe I should have known that, because it's expected that you know that these are Pythagorean triples. Number 2 is the same thing. There's another Pythagorean triple, 3, 4, and 5. X equals 5. But if you wanted some work, it's 3 squared plus 4 squared equals x squared, but x again equals 5.
On to 3.
On to 3. This one at least doesn't have the initial appearance of a triple, but you can divide the triples by 10 or multiply them by fractions. Lots of things you can do. This is a, this is b, and this is c, and we're just using a squared plus b squared equals c squared. 11.9 squared plus x squared equals 14.7 squared. So you solve for x. X is the square root of 14.7 squared minus 11.9 squared.
What does 14.7 squared equal?
I don't know. I'm gonna look up. I'm gonna grab my calculator. I don't have that. I don't have that knowledge handy. It's. I'm just gonna give you the final answer, though. I mean, this is where it would go right to the calculator. You wouldn't do intermediate steps.
Yeah, I definitely wouldn't.
So 8.6 is the value of x for that one.
Is that the whole answer, or is that the work?
That's it. I mean, everything over here is the work. I guess it's.
And it equals x equals 8.7. All right.
Number 4. So the thing that's maybe most difficult is you have to identify the 3 sides. A and B are always the legs. C is always the hypotenuse. So you got 6.3 squared plus x squared equals 15.4 squared. So x is equal to 15.4 squared minus 6.3 squared, and you just punch that into your calculator. See what comes out here. 14.1.
14.1 mile. All right, on the number 5.
All right, this is another Pythagorean triple. This is a multiple though. So the like it doesn't look like, let me get it snipped in. It doesn't look like a triple, at least wait, I'm sorry. It is not a triple. I saw something that wasn't right. ABC. So we got x squared plus 13 squared equals 15 squared. So x is equal to the square root of 15 squared minus 13 squared. I guess this one says to answer in simplest radical form, which means you really shouldn't use a calculator. This is 225 minus 169. That's the square root of 56. And then you're supposed to reduce that. So 56 is 2 and 28, 2 and 14. So it becomes 2 square root 14 is x.
That's weird, and it looks like it was simplified into something else. All right,
Yeah,
on to number 6.
looks like it would work out, but it doesn't.
Yeah, you think that there would be like another 4 that you could pull out, but you can't.
No, yeah. Okay, so this is your A, this is your B, this is your C. This is actually a 30, 60, 90 triangle.
Mhm.
And with 30, 60, 90s, the short leg, which is this one right here, and the hypotenuse is x, and then the long leg is x root 3. So your x in your problem is 8. 2 times 8 is 16. So x right here, this x is 8 square root 3. We can do the Pythagorean theorem, but I think you also know special triangles. So it would be good to.
Wait, so x squared. Oh, wait, so a squared plus x squared equals 16 squared. That ends up equaling, what was it again?
Well, it ends up being 8 square root 3 when you're all done.
8 square root 3. All right. Number 7, find the missing side of the triangle. Just label that out. 11 squared plus x squared equals 15 squared. 15 squared is like, what is it? 225.
25, yeah.
225 minus, what is it, like 110? Wait, no, 121.
121.
That equals something like 104.
Yeah, so we got 11 squared plus b squared equals 15 squared. 225, 121. So b is equal to the square root of, what'd you say, 104?
Yeah. Can you simplify that out at all?
You can. So it's 2 and 52. 2 and 26. So it becomes 2 square root 26. Last one here. Great. We're going to
Awesome.
get this in. All right, so we have a squared plus b squared equals c squared. So it's the square root of 6 squared equals 4 squared. A squared plus 6 equals 16. So a squared equals 10.
Square
A
root of
equals the
10.
square root of 10.
That's like 2 root 5 or something.
It's the square root of 10.
No, oh wait, never mind. You just leave that.
Doesn't reduce, unfortunately.
That's the lesson. Thank you.
Yeah, great, Jack. I'm glad we got this in. So we'll see you tomorrow at 9:30. If you don't need it, let me know. I'll have no problem rescheduling you for that another day.
Awesome.
Thanks,
Thank you
Jack.
so much.
See
Have a
ya.
nice night.
You
Appreciate
too.
it.
Bye.